Let's just play along and act like everything is very clear. And if you see me leave suddenly, you all know why. It's not you, it's definitely me. So I want to talk today about containers, Linux containers, not shipping containers or things like that, and the future of open source software delivery. And the reason I specify open source, of course, is because things like Docker, despite the deal with Microsoft, those are really open source innovations, and they're really things that work best with Linux, not with, say, Windows or Macs, things like that. My name is Joe Brockmeier. I work on the open source and standards team at Red Hat. It's a wonderful job. I am the community team manager, so I manage folks who work with communities. Previously, I was mostly focused on Project Atomic, which is why I am here today. If you would like to get in touch or ask questions after this talk by email in a venue where I can deal with throwing up or other things at leisure and then answer your question, that's my email, and my Twitter address is just JZB. So that answers that question. What I want to talk about is the problems that we face as a community in deploying software. I want to talk about a very brief history of free and open source software delivery. I want to talk about the promise of containers. There is a lot of promise. Is anybody in the room not familiar with Docker? Okay, seriously. Okay, all right, all right. I'll believe you. I'll also mention briefly a couple of other container technologies, but really Docker is far and away the one that is getting the most attention, developer time, and so forth right now. I'm also going to talk about the problems we need to solve. Docker was invented, or at least it was first unveiled in March 2013. I have been in a previous life, I'm a recovering tech journalist. I was the OpenSUSE community manager for 2 years. I worked for Citrix for a year doing cloud stack work. And I've never seen a technology take off like this. It took years. Virtualization was immediately very popular, but it didn't take off this quickly. People weren't struggling to adopt virtualization this quickly. Trying to think of other technologies. Infrastructure as a service, very, very popular. People were very excited about it, but again, people were not trying to adopt it that quickly. So I'm going to talk about problems we need to solve that are yet unsolved with Docker. I want to talk about Project Atomic, which is a project that I work on. And then I will talk about some of the sub-projects there. Thank you, Julie. Thank you. And if I am still standing, I may entertain questions, or I may run out of the room. We'll see what happens. All right, so let's talk a little bit about the problems that we face. And when I talk about the problems we face, I mean as people who are deploying software. How many folks have been using Linux since the 90s? Okay. How many of you, and I'm assuming it's almost all of you, have done the make, configure, install dance, right? Okay. And then how many people actually predate things like RPM and Debian packages? Okay. So you remember the wonder that came along with, like, someone compiled this for me, and I can just install it on my system. And then we all learned about a wonderful thing called dependency hell, right? And I should also note that at that time, open source really accelerated, and the internet really accelerated software development. But it was still at a reasonably manageable pace, right? You got your Slackware updates once a year or so. Red Hat and Debian, well, I mean, if you can't keep up with Debian stable updates, I just don't even know. But basically, the pace of software development was much slower, and much less attention was focused on open source. There's much less exciting stuff going on. So in the beginning, we had tarballs, and then we had packages. And then we had yum and apt-get, which was amazing. We had something that did dependency resolution. You could say yum install foo or apt-get install foo, and it would go, well, if you want foo, you need these 20 other packages, and I shall get them for you. And it was wonderful, right? So what happened then was that Linux distributions sort of became the center of the universe for a while for software development. If you wanted people to get hands-on Apache, if you wanted people to get hands-on Perl or a higher level application, you really wanted Debian and Fedora or Red Hat or whoever, SUSE, to pick up your stuff and package it and ship it with their system to make it easy for their users, right? Now, of course, I say that as a generality. There were always people, of course, who were a little cranky about the changes distributions made to tame their software for the packaging. But in general, projects would spend a lot of effort getting into distributions. And then something happened. We started seeing 6-month updates for GNOME. We started seeing things moving very, very fast. We started seeing developers wanting the latest and greatest PHP, but the installed systems, you didn't want to update the entire installed system just to get the latest PHP. And so we started having language-specific delivery vehicles, which are a nightmare for system administrators, but make developers very happy, okay? And we have things, fairly new. Anybody heard of Colin Walters? Nobody? He developed something several years ago called GNOME Continuous, which if you're a GNOME developer, or if you've ever tried to compile GNOME, especially a development branch of GNOME, you know what the word pain means. I hear that they are actually talking about updating the dictionary for this specific, use case. It's not fun. So he developed a system that would allow you, it would do continuous builds of GNOME, hence GNOME Continuous. He's a brilliant guy. Naming things, but he did GNOME Continuous as sort of a Git for operating systems. So you could check out a branch and boot into it and then revert back to your stable known good system. And that's what OSS-tree and rpm-ostree provide, and I'll talk a little bit more about them later. So we're getting into ways of figuring out how do we deploy robust systems with atomic updates. There's that word atomic, and there's a reason why we call it Project Atomic. And then finally, containers, okay? We start seeing people deploying things in Docker, and I put the question mark here because who knows what's going to come next? Everybody likes to, I'm saying that containers in the future of software delivery are, it's going to be important, but I would be remiss to say this is it, this is the end of the line, this will be the last technology, because we all know better, right? Something else better will come along, but until we get there, this is what we got. So what do containers offer that RPMs don't, or things like that? How many people remembered when virtual appliances were going to solve all of our deployment problems? Have they solved all of our deployment problems? No. Okay. I'm sorry? They are great for demos. So are containers, depending on the software. Now, containers are not new. Remember I said that Docker was launched in March 2013, but actually containers in a primitive form started in the 80s with Truth. And then you had Linux containers and Linux vServer, and you have Solaris zones, and you have FreeBSD jails. So there are a lot of things that have offered that kind of technology. Docker itself was initially based on Linux containers, LXC. But Docker refined the process a lot to make it very friendly for the end user, and not only a technology to run the containers, but an easy format to share, an easy way to make a container file, and so forth. They're very easy to automate. It's easy. A lot of people are using Docker containers as a step in their workflow where the developer checks in code, the code goes through CI, continuous integration, continuous delivery, goes through all the tests, whatever, Jenkins, yada, 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 comes out the other side, and eventually is built into a container that is deployed, and that entire chain can be automated. It is not easy to do that. It's possible, but it's not easy to do that with, say, virtual appliances. And there's also a lot of benefits in terms of resources where you can stack a lot more containers. Unfortunately, I didn't put the statistics in this slide, but we had someone internally spend a little while banging on, how many containers can I spin up on an average machine, and versus KVM machines. And if you go Google it, or when I feel better, I will share it on my Twitter account again. With something like 4,000 containers running on one host before things slowed down significantly. The use of a container, which uses a system kernel and so forth and doesn't require a full VM, is a lot less resource hungry than a virtual machine. The other promise of containers is because Docker is open source and because these other things are open source, like Rocket from the CoreOS folks and systemd spawn from the systemd folks, or whatever comes next, we can all work together to solve these problems, which is better than, you know, say trying to adopt VMware and whatever it is they hand to you, right? Obviously, we have that benefit with things like KVM and Zen, but overall, containers are a technology that was basically, especially Docker, kind of born of open source and guided by open source. So for the one or two people who don't know what Docker is, it is a platform for distributed applications for developers and admins. It makes it easy to get out of the problem of, well, it worked on my machine, because you're basically packaging up the runtime environment in total and shipping that, as opposed to scripts that may or may not work because of the libraries that are running on a certain system, things like that. There are, I don't want to say that this is 100%. There are corner cases where you can have one container, like you can do fun things like, let's say your application is only packaged for Fedora, but what you have in production, it's only packaged for Fedora 22, but what you have in production is CentOS 6. You can run Docker containers that are the Fedora 22 runtime and run that on top of your servers that are already in production without having to change anything except putting Docker on those systems. But there are corner cases where, for example, you get into things like the container expects a mounted volume to have SE Linux permissions set in one way and they're actually set in another way, and the container won't quite work. There are some corner cases where things will actually not just work 100% of the time, but those are rare. Docker is both, one of the confusing things about Docker is they've used the name to describe the engine that runs the containers, the CLI for managing the containers, and the format of the images. So it's a little bit confusing unless you just sort of go with it. You can call it very lightweight virtualization, but it's not real full virtualization, and it is buzzword compliant. So why Docker? It is, for, again, with the caveats I listed before, very real, write once, run anywhere. Packaging, you don't need it. What I mean by that is, let's say you have an application that's going to be based on Fedora 22. Has anybody read the Fedora packaging guidelines or looked at them? They're a little complex. Now, there's a reason for that, because the folks that package Fedora want everything to work in all these different use cases. But for developers who just want to ship something, especially as an internal app, they don't want to have to deal with packaging things as RPMs. They just want to layer it. Java apps. How many people work with Java? Okay. Java does not necessarily play well with Debian or RPM packaging, right? So you can just put your jars in the container rather than having to package them up as RPMs and then ship something. You get consistency. The same container that I'm running here, or the same image that I run and turn into a container, is the same one that I will give to my admin, is the same one that I will give to a customer, and so forth. They're layered. You can build on other people's work. At Flock last year, we had some folks from Yahoo come out, and they have teams. I don't think they're actually using Docker. They're using a different container technology, but it works in a similar way, where one team prepares the base Fedora image, another team layers Apache on top of that with all of Yahoo's special configuration and whatever, and then that is shipped to all the different teams that need to use that container for an Apache-based application. So if you're a downstream team and you're supporting an application, say Flickr, and it's using containers, you don't have to worry about all of the layers except your application. So that makes it much, much easier than having to worry about the entire virtual appliance, okay? Docker is, as I've already said, it's kind of the leader of container innovation. and it makes dealing with legacy much easier. What I mean by that is some examples I've already given. People are taking, for example, RHEL 6 applications, putting them in containers based on RHEL 6, and then deploying them on RHEL 7 so they can get the benefit of things like the hardware support and new drivers for new systems that are coming out and things like that, or just new memory management and all the other wonderful goodies. And vice versa. If you have an application that needs runtimes that are in RHEL 7 and you don't want to package them and try to deal with all that on RHEL 6 or CentOS 6 if you're using that, then you can run that on top of the other one. There are some problems we need to solve. One of them is security. Dan Walsh, everybody familiar with Mr. SE Linux, Dan Walsh? Okay, well, he is on our Docker team at Red Hat, and he has written a great deal about some of the security problems, both, social problems and actual physical problems with Docker security. There's still a good way to root a machine if you can get root in a container. Okay, there are a number of things that we're tightening up. They're doing a great deal of work on it, but right now security is not 100%. It's not as isolated as a VM. So that's a downside. Provenance of containers. How many people have pulled a Docker image from the Docker Hub so far? Okay, how do you know that that's not malware? You don't. You have a little bit of assurance from Docker. Jerome Padalozzi, I think it was, wrote recently about all the checks that they do. So there are some checks and balances, but really, there's not signing and perfect security there yet. I shouldn't say perfect security. There's not as good a security as it could be. I'm going to ask you to hold that for the end. Thank you. It reduces. We need to reduce the complexity. If you have, and this is one of the technologies we're working on, if you have a multi-container application with Kubernetes, everybody heard of Kubernetes? With Kubernetes as an orchestration layer, it was developed initially by Google, and they have open sourced it and basically said this would work great with Docker. We use it with our own internal technology we've had for like 10 years, and now that the rest of the world has caught up with us, we'd like to share it. So anyway, there's some complexity in deploying an application. I've talked to the guys who do the Colab Officeware suite or the Groupware suite, and they have packaged their application in, I think they said, 21 separate containers. And there's a very complex dependency chain between those, which if you're the admin, you really don't want to have to figure out. So we need a way to install an application that's that complex with the orchestration information and the information about its data and so forth as easily as we can install an RPM. We also need, we really need container introspection. We need to be able to peek into a container and say, is this the latest and greatest? Is it patched? Do we, is this thing got Heartbleed or whatever? Are we up to date with this? Do we know all of the things that are in this container? So now let's talk about Project Atomic. We had launched this last year at Summit, and it's a little bit of an oddball as far as open source projects go. Typically, an open source project is something like Fedora or OpenSUSE or Apache HTTPD, where they ship basically one thing, or they ship a couple of things, and it's all based on that. Project Atomic is dedicated to finding patterns for creating minimal hosts to run Docker containers. And we did not want to recreate the wheel and create yet another distribution. So what we did was we decided to work on patterns and tools that would then be used in Fedora, CentOS, and RHEL, and other communities if they want to pick them up, to create minimal containers, and also the work that we're doing around orchestration, management, security, and so forth. So it encompasses rpm-ostree, cockpit, which I'm not going to talk a lot about here, the atomic command or user bin atomic to prevent confusion, nulecule, which is a specification for complex containerized applications, and then the atomic app, which is a way of deploying them. And I'll explain all these. Not going to go too deep into this, but basically we thought that, you know, running containers on a full rel host is sort of overkill. Okay, you really only need the bare minimum, and we don't want you to install anything via RPM running on that system. We want everything to run as a container. So basically what you get with Atomic is just the stuff that you need. We build the host from a trusted distribution like CentOS, Fedora, or RHEL, and we provide nothing else. This is a point of contention, for example, in the cloud work group for Fedora, where people who are doing development on those things want, like, well, I want tmux and screen because some people like screen and some people like tmux. It's like, well, that pulls in a whole bunch of dependencies that we don't really want on that host. Well, I want Git on the thing so I can do my work in there. It's like, yeah, but you don't want Git when you deploy this, so we don't want to put that on there. You need to figure out a way to use Git and do your debugging on the systems without inflicting it on people who are running 100 or 200 or 300 or 1,000 of these and pushing these images across their network, right? I also want to mention we have made some changes to Docker, upstream Docker, which has been a little bit of a point of contention. But we've made a couple of changes to Docker search and Docker pull. Docker search is what you use to basically talk to the Docker hub or your registry and say, what images do you have for me that match this string? And Docker pull, of course, is just like Git pull. It's like, hey, bring this to me. Show me your containers. What we did was we added additional registries. In other words, the official RHEL registries that are not available on Docker Hub, so that people could search those. If they have RHEL entitlements, they can get those. And someday maybe we'll have an authenticated registry for Fedora and CentOS where you get the, I know that I'm getting it direct from the project. Docker search, instead of just listing a short name, like typically if I search for Fedora, the official Fedora project stuff will show up first, and you'll see things like Fedora 21 and Fedora 22. This will list the full URL where you're getting that image from, so you know exactly where it's coming from. We have the ability to block registries, which is important because if you're deploying this in a secure environment or a company where you don't want people grabbing things from Docker Hub or somewhere else, you can basically say, no, do not let my admins grab just anything. Now, it's the ability to block registries. Out of the box, we don't do that, but you have the ability. And we also can warn on push, which is important because we don't want people accidentally uploading things that might have corporate secrets or organization secrets in them to the Docker Hub. These are, by the way, all things that are open source. These are all available on Dan Walsh or either Project Atomic or Dan Walsh's Git on GitHub. And we have tried to upstream them, but we have not yet come to agreement with Docker on how these should look or be implemented. So until we do so, we're going to carry a patch set. We don't like to do that. We don't really want to do that, but sometimes you have to. So I've already talked about rpm-ostree and OSS-tree, so I'm going to skip through this here. But if you ever meet Colin Walters, buy him a beer or a coffee or something because he's done some amazing work. The reason you want rpm-ostree, though, is RPM basically goes one way, and that's forward. It's not really designed for rolling things back. You can do that with Yum a little bit, but if you break your system, rpm-ostree makes it real easy to just revert to the previous known tree. It creates an installable tree from the RPM, sort of like a Git tree, and it's a atomic update. So basically, I do atomic host upgrade. It checks and sees if there's an update. If there is, it brings it down. It tells me all of the RPMs that have changed, and then when I reboot, I'll be in that new tree. If something breaks, I can do atomic host revert or rollback, and I will get the previous system. The atomic command I've already described a little bit. It's the coherent entry point to the system. It basically allows you to manage Docker containers, atomic apps, and it allows you to manage the host itself. It uses the label patch that was added to Docker a few months ago to hold the information about how a container should be run. So if you've done much work with Docker, you know that Docker commands can get silly long once you're doing things like saying, okay, I want to start up this container with this port exposed and and matching this port on the host system, and I want to mount this volume, and I want to do this, that, and the other. The commands can get silly long. I want to give this thing privileges or whatever. Instead, if the developer knows how it should be run, they put that in the Docker file label, and then all you have to do is atomic run, and that will automatically see that and do it. Okay. You can find the source on GitHub there, and then developer blog. Dan Walsh has a really good post about the atomic command. Atomic command enables what's called super privileged containers. As I've mentioned, we don't want to run anything. We don't want to install anything on the system. We want to run everything as a container. So what super privileged containers let us do, typically you want the container to be isolated and not be able to operate on the host, but sometimes you actually want to, say, run logging, which needs to see the host. Or you want to do something really silly. Jim Perrin from the CentOS team has actually done what I guess you would term sort of a stupid Docker trick, and gotten Internet Explorer running in wine in a container that you could ship and run, which is just ridiculous and beautiful in a very hideous way. But basically, super privileged containers have greater access to the host, and it allows developers to package and ship complex toolkits and software. These are some examples of some of the things that we're shipping now that we're offering. Basically, tools container image, so if you need to do debugging or whatever, you can run a super privileged container. And the nice thing about this, too, is containers can be like a nice little admin toolkit that you carry around and install on a system, do your work, and then remove it, and you don't have to worry about what you're leaving behind. There's an rsyslog container image and an SADC container image, depending on what sort of logging and so forth you want to do. And eventually there will be more, and we'll also be shipping some of these types of containers in the community as well. So nulecule. Anybody familiar with this word? Any Simpsons fans? No? Naming things is one of the hard things in IT. And we decided to come up with a unique name for this. We wanted a specification for containerized applications, and one of the folks, Ian McLeod, basically was like, well, what about nulecule? He has a comprehensive memory of like all the 80s and early 90s Simpsons episodes, which comes in surprisingly handy. So basically you can define a complex application in a single standards-based portable format. I do want to stress that right now the work is focusing on Kubernetes and Docker, but we want it to encompass Rocket. We want it to encompass Mesos. We want it to encompass stuff that comes after those. We really want, we've gone through RPM and Debian packages and couldn't get the industry to agree on one format. We've gone through Yum and apt-get and Zipper and things like that. We couldn't get the industry to agree on one thing there. We're going to take another crack at it and try to get people to just adopt one way to work with containers, even if you're using systemd nspawn and Kubernetes instead of Docker. Okay, we want that abstraction layer to be across the board, and we hope people will come along with us. So Atomic App, this is an app that's packaged as a container. What we do is we use a container format to ship metadata about all the other containers, data volumes, and Kubernetes or whatever. We package all that up in basically an empty container that's not going to be run in and of itself, but is going to provide the information for the Atomic command to unpack and run those things. So it's used to bootstrap the containerized apps and run them. It's designed to be run in a container context. And an example here, if you wanted to just run Zookeeper easily, Atomic install vpavlin/Zookeeper Atomic app would grab that and start it up for you. Well, actually, I'm sorry, it would grab that and install it for you, and then you would need to do Atomic run this container name, okay? So basically what we're trying to do is make containerized applications as easy to install and run as RPMized applications or using Yum, okay? So this is where you would find the website, our GitHub. We are an open project. I welcome and love when people want to contribute, or if you have questions, you need help, I want to, again, if I haven't emphasized this enough, we work very closely with CentOS and Fedora to produce these, so you can now get an atomic host based on the Fedora 22 cloud image, and you can get probably in the next week or so a CentOS rebuild of the RHEL atomic host. And we are also working on having a more frequent sort of testing image from the CentOS builds that people can follow along if they want to see how things are working. Okay, I am feeling rough. I'm going to take like maybe one question, and then I thank you for your indulgence. You guys have been so nice. Anybody have just one easy question? Go nice. Wow. Okay. I'm not really sure. Either Bojangles or we went to a whiskey and burger place downtown. I don't remember the name of, but I know that it was not just a fun night out because another member of my party also has this sickness. So it's definitely, we caught something. I don't know. But for those of you at home, this is probably completely irrelevant. But anyway. All right. I'm going to shut it down. If you have questions, please email me or hit me up on Twitter. And thanks again very much.
Citrix Zen Server gives you everything you need to integrate, manage, and automate a virtual data center, all on an enterprise-class, cloud-proven virtual platform, and at a third of the cost of other solutions. But why even bother with virtualizing your server infrastructure in the first place? Well, let's say you have a traditional one server to one application architecture, but you're running out of resources and performance is suffering. Once you order new server hardware, you'll wait for delivery, configure it, install your business application, stage and test the server, and finally, add it to your production farm. If you've been through this process before, you know it can take weeks or even months. You also know it's a manually intensive process that will burden your team every time you outgrow your current setup. With a virtual server solution, you could accomplish all of that in less than half a day. Server virtualization software separates the OS and application from the underlying server hardware. And with multiple virtual machines on a single server, you can use each of them to run different OSs and applications. This makes it possible to move your virtual machines from one piece of hardware to another whenever you want, to maximize utilization, simplify maintenance, or recover from a hardware failure, and without slowing down your applications or users. Clearly, server virtualization provides big benefits, and Citrix Zen Server provides even more. Since it's built on an open platform, Zen Server plays well with your existing hardware, storage systems, and IT management software, as well as with the industry's leading cloud service providers. Best of all, you can get started by downloading a fully functional, production-ready version of Zen Server for free. After a 10-minute installation process, you'll see how easy it is to start virtualizing your workloads and automating your IT management processes. And when you're ready for a richer set of management tools, just upgrade to one of the premium editions of Zen Server. So whether you're interested in virtualizing servers for the first time, expanding your server virtualization footprint, or moving server workloads to the cloud, download and install Zen Server today and see how it can help you simplify your IT environment. Citrix Zen Server. Do more. Don't spend more.
What customers rely on your website or application? If it's slow or non-responsive, it infuriates your users and costs you money. Keeping your business-critical systems humming along requires insight into what they're doing. Your system metrics tell stories that can reveal performance bottlenecks, resource limitations, and other problems. But how do you keep an eye on all of your system's performance metrics in real time and record this data for later analysis? Enter Longview, the new way to see what's really going on under the hood. The Longview dashboard lets you visualize the status of all your systems, providing you with a bird's-eye view of your entire fleet. You can sort by CPU, memory, swap, processes load, and network usage. Click a specific system to access its individual dashboard, then click and drag to zoom in on choke points and get more detail. Comprehensive network data, including inbound and outbound traffic, is available on the Network tab, and disk writes and free space on the Disks tab, while the Process Explorer displays usage statistics for individual processes. The System Info tab shows listening services, active connections, and available updates. Adding Longview to a system is easy. Just click the button, copy the one-line installation command, then run the command on your Linux system to complete the process. The agent will begin collecting data and sending it to Longview. Then the graphs start rolling. Use Longview to gain visibility into your servers, so when your website or app heats up, it stays up.